Hello, today we will be talking about the additional field test. The field test that we study already is so-called SPT or S is Standard Penetration Test. We study about this one already. The concept of this one, we apply the dynamic load on the anvil and blow the split sample, and we count the unit from SPT is blows per foot. This one is SPT, and also from SPT energy is lost. Now we have already the energy about 60% of the applied energy to the hammer. So we go to the next part of the testing. Instead of we apply the dynamic load, it's not same as the load applied to the building, applied to the pile and so on. The load we apply to the foundation is static load. So we change the testing from dynamic load to static load. The static load, first one is so-called cone penetration test. The cone penetration test, the concept as we testing for the small pile. Testing for the small pile is something like that. When we apply the load on the pile, the resisting force is the first one is so-called friction. Second one is so-called bearing. Friction and bearing. If we can, when we test is if we can measure all together how much of the friction, how much of the bearing, we can use the amount of the soil resistance to calculate or to predict the pile behavior, to calculate the pile that can resist the load from the structure. Okay, so we adopt this concept so-called cone penetration test. The cone penetration test, the short one we call CPT. We have the miniature cone. The diameter of the cone about 35.7 millimeter, and we install the load cell. The cell is the instrument to monitor the load applied to the cone chip. And also we have the other load cell installed here. The first one is bearing. The first one is bearing. Second one is friction. We apply the load cell together. So that means when we measure how much of the friction, how much of the bearing of the soil, we can know the magnitude of two components is real time. Real time, that means when we test, we conduct the signal to the data logger and we connect to the computer, we can see what's going on. Sorry, this one actually is not advanced. We test it in Thailand also. The big projects such as the airport, Suvarnabhumi Airport, we conduct some of the ground improvement of the soil, and after that we use this kind of method to check whether the ground improvement is okay or not, or is the effective of the ground improvement. We use this one to check it. And it's not only Suvarnabhumi, there are the new project in Thailand is so-called Utapao Airport. They apply some of the compaction to the soil. We use this kind of test to check the level of compaction that is passed or not, on what is the relative density of the soil. We use this one. This one is quite fast. And right now the cost for testing for one location actually is not quite expensive. In Thailand, I think it's about 7,000 baht per one location. That doesn't mean if you would like to construct a house using this kind of equipment, you can know the pile capacity immediately. If we compare this one to the test, the soil boring, we have to send the soil to the lab. We have to test it. We have to wait for the result. We have to make the soil report. We have to divide the soil into a layer. It spends really long time. This one is really short. And the other one is so-called vane shear test. The wind shear test is something like this. They have the wind shear. We insert this kind of wind shear into the soil. The wind shear is something like this. Okay, and we connect to the ground surface and we rotate it. When we rotate it, when it rotates, it will create something like this. Okay, from the ground surface, we measure for the torque. And after that, we can calculate the amount of SU or undrained shear strength of the soil is the amount of resistance that is come from the soil. How to calculate? For the undergrad program I will teach you, will study this one when you study in master degree. This one, the one that I let you to know, this one is really useful for using in the soft clay. I always use this test in the soft clay because it's fast. When you rotate it, you know the torque, you can estimate the amount of SU immediately, and it's cheap, it's fast. And the other thing is that your soil is undisturbed. Undisturbed, that means you test the soil directly in the field, and you know the result from the field also. This one is quite good. Same as I mentioned before, we rotate. The wind is rotated here. The resistance comes from the top and come from the side. We can calculate the SU from the field immediately. And the other one, this one is quite advanced, is so-called pressure meter. Pressure meter is something like that. They have the tube, and we install into the soil and we apply the pressure to the pressure meter. And this part is made from the rubber, it will expand. The concept is like this. We insert the pressure meter to the soil, something like that, and we test it. After that, we remove this one. So this test, we can measure the deformation. It's only one field testing that we can measure the deformation. If we know the deformation of soil, we can calculate for the stiffness of the soil. If we compare this kind of test with the previous test, SPT, we calculate only for the strength. We test for the what you call the CBT, we know only the strength, the bearing and friction. For the wind shear, we know the strength, but this one we know about the stiffness of the soil. And if it's not stiffness of the soil, we can calculate. I think you guys can remember. It's the K naught. It's at rest earth pressure. It's at rest earth pressure. Why we have to know the at rest earth pressure? Because if we would like to design for the channel in the soft ground, we have to know it to balance the earth pressure. This one is quite advanced, and for the big project, we always use this kind of testing, such as the really tall building, the channel, and the deep underground excavation. You can see that a lot of the new project in the world, they always use this kind of pressure meter. Burst is this one, I think you know, is Burj Khalifa. They use the pressure meter to test the stiffness of the soil as the ground surface. They can calculate what is the settlement. And also they have the Freedom Tower in New York. They use the pressure meter. Also Shanghai Tower, they use pressure meter. And our Albert Tower here in London, they will use pressure meter. Petronas use pressure meter. Sears Tower in Chicago. So this one is Burj Al Arab, is in Dubai. And Empire State is really long time ago. They use the pressure meter to see the stiffness, what kind of stiffness of the underground behavior. This one is, as I told you, that it's only one test that calculates the stiffness. And also they have the new project is so-called Nakheel Harbor and Tower in Dubai. It's tall about 1 kilometer. It's really far from the ground surface. They have a lot of load acting to the ground, so we have to calculate all of the tall building. We calculate for the stiffness. have to know the stiffness of the ground to estimate the settlement.